Hey everybody, and welcome to this session for the Festive Tech Calendar 2021. I'm Marco Obinu. I'm a guy with a strong passion for all Azure-related topics, and I'm working as an advisory engineer for SoftGem, an Italian Microsoft partner. If you want to stay in touch with me, just follow the link on the left where you can find all my social media references. Today, I'm here trying to help those poor elves we've just seen before, and to do this, we'll try to implement an infrastructure as code approach that helps them while preparing their gifts. Before entering into the technicalities, I'd like to spend a couple of words about this awesome open source domain-specific language that targets Azure deployments. Well, Microsoft and the community support this language for doing infrastructure as code on Azure, and it implements all the classical benefits that normally ARM templates have, like, for example, a nice integration with other Azure services, as well as being officially supported by Microsoft and so on. If you want to go deeper into this topic, please have a look to the Marcus Felling blog post linked below in the slide. Apart from preserving these ARM template benefits, Bicep want to also address all the issues that you may face while working with JSON ARM. For example, Bicep offers you a more clearer syntax and that is way more readable than JSON ARM, and it also improves the reusability of your code through a modular approach. Now, let's leave apart the theory for a minute and jump into a specific scenario we will try to address. Let's say our elves have received a couple of Christmas letters, both from John and Cindy. John is asking for a simple blog post, and so our elves should deploy a small app service, let's say in West Europe, to support this kind of request. On the other side, Cindy is asking for a more complex scenario to manage a business-critical web application and its dev environment. In this case, our elves should deploy a geo-distributed, load-balanced web application composed by multiple instances of app service distributed in different Azure regions, and side by side with a smaller configuration for a dev environment. Now, we want to reduce the effort for our elves, giving them a solution that minimizes the number of different Bicep files they have to author to prepare these two gifts. To achieve this, we'll leverage the dynamic capabilities that Bicep offers us in terms of syntax to reduce the number of scripts we need to author, and we'll also leverage its modular approach to improve code reusability. We'll use a Bicep registry to share these modules between the elves teams, and GitHub Actions to create automation workflows that govern the code's validation, testing, and deployment phases. And finally, to simplify our life while authoring these Bicep files, we'll extensively use Visual Studio Code and its excellent Bicep extension. Now, before jumping into the demo environment, let me introduce briefly some key concepts of the proposed solution, starting with Bicep modules. Well, a Bicep module, in the end, is a simple, plain Bicep file without any special syntax. Instead of declaring all of your resources in a single monolithic bicep file, you can move part of them into another bicep file that will act as a model. Then, in the body of the main bicep file, you can reference the external model and specifying its path and all its required parameters. When you transpile a bicep file that references external modules, the output of the build command is a single JSON file that contains all the resources defined inside the main bicep file, as well as all the resources defined in each module, and these external resources will appear inside the JSON file as nested deployments. So the build process generates a single artifact even if you are working with more than one model. And this modular approach allows you to create a library of reusable modules to share with your team. To improve this sharing experience, you can move them into a Bicep registry, which is an Azure Container Registry behind the scene. In this way, instead of using a local path to reference your modules, with all the complexities that came from a file sharing approach, you can switch to calling them directly from the ACR. At the build time, the CLI downloads all the needed modules and merges them into the main bicep file as nested deployment, as usually happens with local modules. Let's talk now about continuous integration and continuous deployment. Well, generally speaking, with the Bicep CLI and the tools that implement it, like, for example, the Azure PowerShell module or the Azure CLI, you have all the instruments you need to implement a CI/CD pipeline. Bicep CLI natively integrates the linting rules that are normally available through the ARM template toolkit tool. Thanks to a configuration file that we will see later during the demo, you can configure these rules to throw an exception instead of the usual warning when they fail. And so this is useful to block a CI workflow if the file can't pass the validation phase. After this linting stage, you can leverage a deployment command like UAZ resource group deployment, commandlet in PowerShell, to create a stage that executes the pre-flight validation of the Bicep file and evaluate what are the proposed changes through a what-if deployment. When you're ready, you can add a third stage that reuse the previous commandlet without the what-if parameter to deploy the resources in a target resource group or other or in another scope. Now, in our scenario, we need a different approach. We don't need a CI/CD pipeline that deploys the gifts in the Lucy and John subscriptions. Instead, we want to create a CI/CD workflow that helps our helps while authoring their modules. And so this workflow will manage the code validation phase for our modules and publish them into the Bicep registry. To do this, we'll store all our module in a single folder in a single GitHub repository managed with a shared repository approach. Our apps will work on their own branches. Each push that occurs on these branches will trigger a GitHub action. This GitHub action validates only the modified Bicep file inside the folder and deploys them on a test resource group. When they feel confident with their Bicep files, the elves can open a pull request to promote the changes into the main branch. And this activity triggers another GitHub action that validates the content of the pull request. If everything is okay, the Elves team leader can approve the pull request and merge it onto the main branch. And this trigger an additional GitHub action that publishes the updated Bicep file into the registry. Once published, the Bicep file that generates the gifts can consume the modules from the registry. And as of now, the Bicep registry is a private resource that resides into the Elves subscription. This means that they can't send the gift Bicep files directly to John and Lucy because if they want to use them, they can't reach the Elves Bicep registry. Instead, our Elves should transpile those Bicep files into JSON ARM templates that contains all the resources, including the ones generated by the modules in terms of nested deployments, and then send the JSON ARM templates to John and Lucy. Okay, it's time to jump into the demo environment, and let's start having a look to the GitHub repository that contains this demo. Now, for the sake of simplicity, in terms of sharing this repository with you, I prefer to collapse both the modules and the GitHub action that covers them and the gift bicep files for Cindy and John inside the same GitHub repo. So let's do a quick inventory of this repository. So if you want to try this at home, you know where to put your hands. Let's start with this folder, the GitHub workflows that contains the YAML definition for the pipeline related to the GitHub actions. Then we have an environment preparation folder that contains this deploy PS1 script, a PowerShell script that permits you to deploy this demo environment in your own subscription. Then we have the modules folder that contains our modules, and it's the place where the pipelines, the GitHub actions, will look for updates to trigger the push of the modules into the Bicep registry. And then we have this scripts folder that contains a PowerShell script used by the GitHub actions during their execution. In the root folder for the repo, I placed my Bicep files for the gift 1 and gift 2. As you can see here, we currently have only one branch, and let's have a look to the configuration of this repository. First of all, in the branches section, I defined a branch protection rule for the main branch that impose a pull request with approval to merge into the main branch. Additionally, I also defined a secret, the AZCred secret, used to deploy resources in Azure. It contains basically the service principle used by the pipelines to deploy resources in Azure. Now, let's move to VS Code. Let's now have a look to the Bicep modules. Inside the modules folder, you can find 3 different files. Let's start with the Bicep one. This is a simple Bicep module that produce an app service and its related app service plan. And this module will be used as the baseline for the preparation of our gifts, both gift 1 and gift 2. These modules ask you for a bunch of parameters like the web app name, its location, the tier, and the number of instances you wanna set for your app service plan. Then it defines an app service plan resource named hosting plan and a app service resource named web app that references the hosting plan ID to define an implicit dependency between the web application and its app service plan. Then the module defines a couple of outputs, the web application ID and the app service plan ID that can be used later in other Bicep files. Now, we've said before that we want to test each push made by the elves to check the validity of the code and in terms of linting rules and validation, pre-flight validation checks, as well as by deploying the module into a test resource group to be sure that the content of the module can generate the required resources. For this reason, along with the Bicep module, inside the modules folder, you can also find the bicepconfig.json file and the webapp.parameter.json file. The bicepconfig.json file defines the behavior of the different linting rules when the file is transpiled from the Bicep file to the corresponding ARM template. As I was saying before during the slide, by design, the linting rules enforced by Bicep throw warning messages when they fail. Now, since we are working with the CI/CD workflow and we want to stop it if a validation check fails, we need to increase the level of the message produced by the linting rules. And here you have to change this level from warning to error to achieve this. Additionally, when it comes to deploy this module into a test resource group, you need to assign some values for the required parameters. And to do this, I also included into the folder a ARM template parameters file that defines these test values. You should also know that when you want to push a module into a Bicep registry, you also have to tag it with a version number. Now, you can define different ways to manage this version number. In my case, I decided to create a version number starting from the content of this property included by default into any ARM template parameters file. This content version property contains a free value, a value that you can define as you want, and so I decided to use it as my version number for the Bicep module I want to push into the Bicep registry. Let's see how it works. First of all, let's create a new branch for one of our elves, and let's name it elf1. Then let's introduce a couple of changes to this Bicep module by, for example, changing the comment here and increasing the version number here in the parameters file. Now we can push these changes and this should trigger a workflow on the repository. Let's have a look at it. Let's jump into the action blade, and as you can see here, the CI/CD GitHub action is running. Let's have a look to this workflow while it works. Let's zoom it a bit. And this is the CI/CD workflow that is running right now. It works on every branch excluded the main one, and it looks for changes to Bicep and parameter.json files inside the modules folder. It runs onto an Ubuntu latest runner, and the main action it does, the main steps it does are these. One, this is an action I found in the marketplace to get the modified files from the different commits, and then after doing an Azure login, I use a PowerShell action that build the ARM templates for the modified Bicep files and then validate them in terms of linting rules, pre-flight validation checks, and then this action also deploy the Bicep file to a test resource group. And I used an Azure PowerShell action to be able to define a custom logic inside these steps. First of all, I retrieve the list of modified files from the action we've just seen before, and then for each modified Bicep file, I retrieve the module name, its related parameters file, and if everything is okay, I execute a new Azure resource group deployment commandlet passing all these values and the what if parameter. This does the transpilation of our Bicep files into an ARM template files, and so enforces the linting rules. And then if everything is okay, it also execute a what if deployment onto the resource group to do the pre-flight validation checks. Then I have an additional step in my workflow that do the exact steps we've seen before, but in this case, it execute the commandlet without the what if parameter, and this execute the deployment into the test resource group. In the meanwhile, the workflow finished, and as you can see, all these steps have been completed. And you can see here we have a what if execution that changes these parameters into the deployment, and then we have a deploy of the module into a test resource group. Now, if we jump into the Azure portal, inside this test resource group, you can find the resources that the GitHub actions deployed via the Bicep module and its related ARM templates parameter file. Now, let's come back to VS Code and open a pull request to merge these changes into the main branch. Let's create it. And this triggered the execution of an additional GitHub action pipeline to check the content of the pull request. Let's have a look at it. Okay, this one is quite fast, and this pipeline is triggered by pull request that occurs in the main branch and looks for bicep and parameter files modified inside the modules folder. As before, we have a step that get all the updated files, and we have a second step that execute a PowerShell script that do some checks. This PowerShell script look that for each updated bicep file, it's present a corresponding parameters file. If we miss the parameter files in the pull request, the workflow fails. This is due to the fact that we are using the parameter files for defining the version of the updated bicep model. If an elf is trying to merge only an updated bicep model without the corresponding parameter files, this probably means that he forgot to update the version of the model, and we wanna block the pull request in this case. Now, let's go back to VS Code. Let's do a refresh of this pull request page, and as you can see, everything is fine. We can merge the pull request on the main branch, and this trigger another action here. Let's have a look to the workflow file while it runs. And as you can see here, this workflow file is triggered on push activity on the main branch. Again, need to look for bicep and parameter files, and we have a step that get the updated files. It does a login on the Azure subscription, and if everything is okay, is looking for the updated bicep modules, and for each updated bicep module, it executes a bicep CLI command, the bicep publish command, to push the updated module into the ACR, into the bicep registry. And this is the name of the module we want to push into the registry, that is composed by this prefix that is BR, then the name of the bicep registry we are targeting, and then we need to specify the module name and the version of the file. The version, as you can see here, is retrieved from the parameter file inside the content version property. This section, in the meanwhile, has finished, and now we can jump into the portal. This is our target bicep registry, this container registry. Let's have a look at the repositories. Here we can find the modules web app module, and now you can find the new version we've just updated. The process we've just seen is the one that an elf should sustain if he or she wants to apply a change to the bicep registry that acts as their shared library for bicep modules. Now, it's time to see how they can use these modules to prepare their gifts. So let's jump back to VS Code. So let's start with the gift one. Here you can see a schema of what we have to deliver for completing this task. John was asking for a place where to host his own blog, and so we need to deliver an app service with its related app service plan. And since we are working in a small environment, we will choose a B1 tier for the app service plan and one instance. To achieve this, we can use this Bicep file for gift number 1. And this is really simple because it only implements the modules we've just created a few minutes ago. Now, as you can see, it asks for a bunch of parameters, and then it defines a module with its own symbolic name, and here you can find the reference to the module into the ACR instead of using a local path to the Bicep module. This name is composed by a prefix BR for Bicep registry, the name of the ACR we are targeting, ACR 5288 in this case, a modules folder, and then the name of the module we wanna use. Then you have also to specify the tag that in our case is the version of the module. And as you can see here, we are using the version 1001. This is the one that we have just pushed into the ACR. Into the params section, you have to specify the parameters required for the modules. And that's all. This gift 1 is achieved with this implementation. Let's jump now to gift number 2. In this case, this scenario we are targeting is way more complicated because Cindy was asking us a way to handle a mission-critical web application and its dev environment. So in this case, we need to deliver both a test environment composed by an app service and the related app service plan in a small size. With this deploy is similar to the ones we did for John. And then we need to deploy a production environment that is composed by an app service and an app service plan. But we need to clone this environment and spread it into 2 different regions, West Europe and North Europe. Also, in this case, since we are working for a production environment, we need to increase the size of the environment, and we are choosing a tier S1 for our app service instances, and we are deploying a couple of instances in each region. Then, since we need to load balance the traffic between these regions, we have to deploy a traffic manager in front to the web applications. We can handle all this stuff with a single Bicep file, that is this one for gift number 2. And to do this, we leverage the dynamic capabilities of the Bicep syntax to iterate between arrays that are different in size for the test and prod environment. Here you can see the Bicep file where we have a couple of parameters that must be passed to the Bicep file, and like the name of the web application, and then we have a parameter environment that accepts test and prod values. Then we defined a couple of arrays that contains different values depending on in which environment we are working. For example, this one that is the environment region array for the test environment contains only West Europe, while the prod environment contains both West Europe and North Europe. Then we have another array with the settings for the app service plan, and in the test environment we will be using a tier B1 with 1 instance, while in prod we will be using a tier S1 with 2 instances for each region. Having said that, you can see here the module definition that recalls the module in the Bicep registry. This is the same exact models we were using for the John's deployment. And in this scenario, we are iterating over the environment region array, looking for the current environment that Cindy chose while deploying. And so we are iterating through this array, and depending on in which environment we are working, we deploy a different number of app service and related app service plan. In the test environment, we will deploy only one app service and app service plan, while in the production environment, we will be calling this module twice and deploy one module in the target region West Europe and the second module in the target region North Europe. As you can see here, also we are leveraging the second array to dynamically choose the tier and the number of instances depending upon the environment Cindy choose for the deployment. After that, if you are working in the production environment, we also need to deploy the traffic manager. And here you can see a traffic manager resource that handle it. But this resource has a conditional approach. So if we are working in the production environment, this traffic manager will be deployed, otherwise it will be skipped during deployment. And to achieve this, we are using this if condition here that leverage the ternary operator that is native to the Biceps syntax. If we are working in the production environment, this traffic manager will be deployed, and so we need also to compose its endpoint array. And to do this, we again iterate between the on the environment region array, and for each region we find in that array for the production environment, we will create a new endpoint that reference the corresponding web application ID that is that we can obtain as an output from the module execution. And that's all for this second gift. A way more complicated scenario, but we can handle it with a single Bicep files thanks to the dynamic syntax that Bicep offers us. We've seen how we can manage a CI/CD workflow for deploying our Bicep modules into a Bicep registry, and how the elves can leverage these modules to prepare their gift. Now, we've seen that the Bicep registry is an ACR resource distributed in the Elves subscription. And so, in our case, John and Cindy can't directly reach the Bicep registry if they don't have enough permissions on the Elves subscription. So, the easiest way for the elves to send their gift to John and Cindy is to transpile them and then send the ARM template JSONs to John and Cindy. Let's do this for the gift number 2, for example. And this is as simple as doing a bicep build command on top of the gift number 2.bicep. This will produce a gift2 JSON, and let's have a look at it. Here you can see the translated JSON arm that is derived from the Bicep file. Here you have the parameters section and the variables section where we have defined the arrays. Then there's a traffic manager resource with a condition that deploys it only if we are working in the production environment, then a copy loop for configuring the endpoints of this traffic manager, and an explicit dependency on the web application we are delivering in the current environment. Then we have a copy loop for the web app creation, and as I was mentioning before, since this is an external module, it's represented as a nested deployment into our own template. And again, we have copy loops that deliver all the stuff we need to obtain the web application. So in this way, instead of sending them both the bicep file and a module, or allowing John and Cindy to reach the module in the bicep registry, you can simply send them a unique JSON file that is an artifact that they can run to create their own gifts. We reached the end of this video, but before leaving, I'd like to share with you some useful links. Let's start with the one that points to the repository that contains the demo we've just seen. And then I'd like to add another repository hosted on Azure DevOps, where you can see a similar example developed with Azure pipelines. Then I'd like to share a third GitHub repo that contains an end-to-end pipeline to build and deploy bicep files with GitHub Actions. And lastly, I'd like to strongly encourage you to have a look both to the official GitHub repository for Bicep, as well as to the Microsoft Learn page for Bicep, because it holds some very interesting learning path around Bicep, and one of them is targeted to CI/CD concept. Well, I think that's all for now. I'm really glad to have been selected for participating to this event. I would like to say you thank you so much for being with me. Grazie davvero, and see you next time. Bye bye. Ciao.